Question 9. Given f of x equals x plus 2 times x squared minus 6x plus 9 equal to x cubed minus 4x squared minus 3x plus 18, calculate the coordinates of the turning points of the graph of f. Now you'll notice that they've been very nice here and they've already expanded our function f of x to this form. They've times out the brackets. So we've been asked to find the turning points. Now what must we think about when they say turning points? Well, what we must think about is, given a graph, the turning points are where the gradient swaps over from a positive to a negative or a negative to a positive. So for example, in a parabola like so, we have a negative gradient over here. We have a positive gradient over here. So it had to swap at some point, and that will be where, so important theory here, the gradient let's denote that by m, where that is 0. So if we are asked to find the turning points of a graph of f, doesn't it make sense to find where the gradient for that graph is equal to 0 throughout? And how do we find the gradient of a given function f? Well, we first find its derivative, because that gives the gradient of that graph throughout for values of x. So let's find its derivative. Now this will be very easy because we already have the expanded form of f of x. So that will be 3x squared minus 8x minus 3. And from here, we can factorize and solve for x where x is equal to 0, because we know that the gradient will be equal to 0 for our derivative. So let's solve for x when the derivative is equal to 0. So I'm going to factorize this now. So I always start my factorization like this. So we know we're going to have a 3x over here, an x over here. We've got a plus here, so we can't say immediately, we have a minus here, so we can't say immediately whatever the middle, whatever the x's coefficient sign is will be throughout, because this is a minus. If it had been a plus here, then we could have said, okay, what's this coefficient? What's the x's coefficient sign? It's a minus, so we know immediately it's a minus minus. But here it's a minus, so we can't use that nice trick. So let's do this now. We're going to check for 3 and 1. What are the factors of 3? 3 and 1. And what are the... So remember, we solved this by saying, what are the factors of the constant? 3 and 1. That's the only factors we have. So what can we times 3 with to give minus 8? Well, we could times it with the 3 over here, and that will give 9. And then minus 1 could give the minus 8, or plus 1. So why don't we do this? Why don't we say minus 3 over here plus 1? Let's check that. 3x squared minus 9x plus x minus 3. Yeah, that gives us this. So just to reiterate, how we solve or factorize expressions like this is we list the factors of the constants. If this had been 8, if that had been 8, well, the factors of 8 are 8 and 1, 4 and 2, 2 and 4, 8 and 1. And then we look which combination. Is it this combination, this combination, this combination, or this combination? When we plug them in here, would give our original expression. That's what we're doing. So I took 3 and 1 because it was the only factor. So all I had to do was figure out, should I put the 3 here or the 1 here? So, but we've solved it accordingly. Well, we haven't solved it, we're in the process of solving it. Now we have to solve actually for our x, but that's super easy. This term, 3x plus 1 equals 0. X will equal minus a third. X equals 0. X will equal 3. And what's the corresponding y values for these x values? Well, we can figure that out by plugging in these x values. So let's do that with the calculator. And remember, we plug it in, not into our derivative, but into our original function, because we want to find for what values of x for our original function is the derivative 0. So all we found here is for the positions of x where the derivative is 0, but what are the actual y values when that derivative is equal to 0? Well, we must look at our original function. So using my calculator here now, 1/3, and I'm a bit slow because I injured my wrist. 1/3, I'm plugging this into the original function just to make sure you guys are following. This is a bit of a long question, but good marks here. Nice marks. One-third minus 4x squared minus 3. Oh, it's a minus. Apologies. It's a minus a third. Minus. I get 500 over 27. And then if it was just a 3, that will be 3 to the power of 3 minus 4 times 3 to the power of 2 minus 3 times 3 plus 18. And that's a 0. So we have solved the points on our graph where the derivative will be equal to 0, and thus where the turning points are. And that is the question solved.